In today's video, we will be sketching all possible types of quadratic graphs. So there are 6 cases altogether, alright, those with 2 roots, 1 root, or no roots. For both a non-inverted parabola, like this shown over here, and for inverted parabolas. So altogether, there will be 6 cases. I will also be saying roots instead of solutions or x-intercepts, because they're all the same. And if you have any questions, please post them in the comment section, and I will answer them. So let's begin. Okay, so for the very first question, we have y equals to x squared minus 5x plus 6. So I recommend doing this quick check, alright? So to make out the rough shape of the parabola, what we do is we compare this with the standard form. This is the standard form, ax squared plus bx plus c. If a is positive, then the parabola will be non-inverted. So it look like this. Okay, and one more thing you can do is determine the b squared minus 4ac. If it is greater than 0, you have 2 roots. If it is less than 0, you have no roots. And if it is equals to 0, you have 1 root. By the way, the b squared minus 4ac is called the discriminant. So a is 1, b is minus 5, and c is equals to 6. This is equals to 1. Okay, so knowing that a is equals to 1, and the discriminant is a positive number, 1, the graph has 2 roots and it is a non-inverted parabola. So it should look something like this, right? Okay, so to sketch our graph, right, we will need to find 3 things. All right, the first is the y-intercept. Second is the x-intercept. And thirdly is the vertex, which is the turning point of the graph. To find the y-intercept, we will let x be 0. This gives us 6. To find the x-intercept, we shall use our quadratic formula. Minus b plus minus square root b squared minus 4ac over 2a. And we are going to substitute our a, b's, and c's into the quadratic formula. So solving for this will give us 2 values of x, where x1 is equals to 5 plus square root of 1 over 2, which is just 3. And the other x value is 2. Let's find our vertex. To find the vertex, we will use the formula of the vertex. So the vertex is the turning point of the quadratic graph. To find its x-coordinate, we shall use minus b over 2a, which gives us 5 over 2. And to find the y-coordinate of the vertex, there are 2 ways to do it. One way is to substitute the x-coordinate of the vertex back into our quadratic equation, which will give us negative 0.25. Or we can apply the following formula, c minus b squared over 4a, where c is 6, b is 5, and a is 1. This will also give us 0.25, negative 0.25. So both methods work. I will be sticking to the first method, where we will be substituting the x-coordinate of the vertex back into the quadratic equation to get the y-coordinate of the vertex. Okay, so putting everything together, our y-intercept is equals to 6, our x-intercept is equals to 2 values, 2 and 3, and our vertex is located at 2.5, negative 0.25. So let's sketch the graph now. So the vertex is located at negative 0.25 here. The y-intercept is 6, and the x-intercepts, there are 2 of them, 2 and 3. So we can trace out the graph as such. Okay, so this is the quadratic graph of the following equation, x squared minus 5x plus 6. As you can see, it has 2 roots, 1 vertex, and 1 y-intercept. So now we will move on to the next case of 1 root and a non-inverted parabola. So this is the equation right here, y equals to x squared minus 4x plus 4. Applying this to the standard form, you can see that a is equals to 1, b is equals to minus 4, and c is equals to 4. So because a is equals to 1 and our discriminant is equals to 0, our graph will have 1 root and it's going to be a non-inverted parabola. So it should look something like this. Now let's move on to find our x-intercepts, y-intercepts, and vertex. To find our y-intercept, we'll let x be 0, which gives us y equals to 4. To find our x-intercept, we shall use the quadratic formula. So x is equals to negative 4 plus minus 0 over 2, which really only gives us one root, negative 4 over 2, which is equals to negative 2. Next, let's find our vertex. So to find the x-coordinate of our vertex, recall that it is equals to negative b over 2a. So let's substitute the values in very carefully. We get 2. To get the y-coordinate of the vertex, substitute the x-coordinate of the vertex back into the quadratic equation. This gives us 0. So the vertex is located at 2, 0. Now that we have our x, y-intercept, and our vertex, we can sketch the graph. So putting everything together, our x-intercept is 2, our y-intercept is 4, our vertex is 2, 0. So let's plot our vertex first. 2, 0 should be located over here. Our y-intercept is 4, and so this is the graph of this quadratic equation where there's only one root and a y-intercept, where the vertex is located along the x-axis. So now we'll move on to a quadratic equation with no roots. What we have here is y equals to x squared plus 4x plus 5. You can see that a is equals to 1, b is equals to 4, and c is equals to 5. And using our discriminant, we can also see that it is negative. And so this graph will have no roots as the discriminant is negative, and it will be a non-inverted parabola. So it should look something like this. So no roots means that it will not touch the x-intercept. The parabola will be non-inverted. So you can expect the graph to have this shape. As usual, we'll move on to determining our y-intercept, x-intercept, and vertex. So the y-intercept we can find by letting x be 0. This gives us 5. The x-intercept, to find it, we have to let y be 0. So we have x squared plus 4x plus 5 equals to 0. Applying the quadratic formula, we'll notice that since b squared minus 4ac is negative, we can't square root a negative number, so there are no solutions or no roots. Now let's move on to find our vertex. So the x-coordinate of the vertex is negative 2. The y-coordinate of the vertex can be obtained by substituting negative 2 back into the quadratic equation. This gives us a value of 1. So the vertex is located at negative 2, 1. Combining all the information we have about the x-intercept, y-intercept, and vertex, we can now sketch our graph. So if you recall, our x-intercept, we have none, because the discriminant is negative. The y-intercept is equals to 5. And our vertex is located at negative 2, 1. So let's plot the vertex first. Negative 2 and 1 is located here, and 5 is over here. The y-intercept is 5. So this is the graph of our quadratic equation. There is no x-intercept, and the y-intercept is 5. Okay, so we are done with the cases where the parabola is non-inverted. And that is a 2-root parabola, a parabola with 1 root, and a parabola with no roots. Now let's move on to the next 3 possible cases where the parabolas are all inverted. Okay, so in this first example, I'm going to show you the case where the parabola is inverted and it has 2 roots. So we have the following equation: y equals to negative x squared plus 5x plus 6. So the same procedure applies, right? Let's compare it to the standard form. Doing this gives us negative 1 for A, 5 for B, and 6 for C. And doing a quick check using the discriminant b squared minus 4ac, okay, we see that it is 49, so it's positive. So we can expect our graph to have two roots, and it is an inverted parabola because a is negative. Let's find our y-intercept by letting x be 0. So y is equals to 6. To find the x-intercept, we will let y be 0, and we shall again use our quadratic formula. There are two x values. x1 is equals to -1, and x2 is equals to 6. Now let's find the vertex. So by substituting the x coordinate of the vertex back into the quadratic equation, we can obtain our y coordinate of the vertex. And that's a 12.25. So the vertex is located at 2.5, 12.25. So what do we have altogether? Our y-intercept is 6. Our x-intercept is -1 and 6. And our vertex is located at 2.5 and 12.25. So this is the graph of our quadratic equation. Let's sketch the vertex first. So this is the vertex. The y-intercept is 6, and the x-intercepts are -1 and 6. Now we can trace out the shape of the graph. So as you can see, there are two roots. The y-intercept is at 6, and the vertex is over here. Next, we move on to the case scenario of an inverted parabola with one root. So we have the following equation: y equals -x squared plus 4x minus 4. Again, comparing it with the standard form, we see that a is equals to -1, b is equals to 4, and c is equals to -4. Also using the discriminant b squared minus 4ac, we can see that we get 0. So because a is -1 and the discriminant is 0, the graph of this quadratic equation will look something like that. It will touch the x-axis once. The y-intercept of the graph, by letting x be 0, is equals to -4. Similarly, x-intercept of the graph will let y be 0 as usual, and we shall use the quadratic formula to find the x-intercepts. So because square root of 16 minus 16 is 0, there will only be one solution. -4 plus -0 over -2 will give us x equals to 2. So x equals to 2 is the only root that exists for this quadratic equation. Next, let's find the vertex. Applying our -b over 2a, we get a 2. We'll sub xv back into the quadratic equation to get yv, our y coordinate of the vertex. This gives us 0. So putting everything together, the y-intercept is equals to -4. The x-intercept, there's only one, which is 2. And the vertex is located at 2, 0. And we have this graph. Which has one root and one y-intercept. Now we move on to our last example, where the graph is inverted and there are no roots. For this, we have this equation here, y equals to -x squared minus 4x minus 5. We are going to compare it with the standard form again. And we can see that a is equals to -1, b is equals to -4, and c is equals to -5. And doing a quick check using our discriminant b squared minus 4ac, we can see that we get -4. So because the discriminant is negative, there are no roots. Now let's find our y-intercept. Again, we let x be 0, and we see that y is equals to minus 5. As for the x-intercept, because b squared minus 4ac is negative, there are no roots, and therefore there are no x-intercepts. So you can check using the quadratic formula. Therefore, because b squared minus 4ac is negative, we can't square root a negative number, and therefore there are no roots, or no x-intercepts. Now let's move on to find the vertex. The x-coordinate of the vertex is equals to minus b over 2a. Substituting in the values carefully, we get negative 5. To obtain the y-coordinate of the vertex, we will sub minus 5 back into the quadratic equation, giving us a minus 1. So the vertex is minus 5 minus 1. Now that we have our x-intercept, our y-intercept, and our vertex, we can sketch the graph. So to recap, the y-intercept is 5, minus 5. The x-intercept, we have none. And for the vertex, it is at negative 2, negative 1. So this will be the graph. Negative 2, negative 1, and the y-intercept is minus 5. Also take note that the parabola is inverted because a is minus 1. So it should look like this. So that's all for all the possible graphs. Feel free to scroll back and watch the example again if you're not so sure and you need a recap. The timestamps are below, and also please subscribe. Thank you.